looking at an equation, two equations that will help us to determine the distance of the image, the distance of the object, or the height of the image and the height of the object based on any one of the variables being given. Now, the first equation that we use for calculating mirrors and magnification, incidentally, magnification is the change in size of an optically produced image. And we're dealing with concave mirrors here. There's 1 over the focal length, which equals 1 over the distance of the image plus 1 over the distance of the object. The image distance di will be negative if the image is behind the mirror. So that's what a negative result will mean. You can use the magnification equation as well. Magnification is equal to the height of the image divided by the height of the object, which is also equal to the distance of the image over the distance of the object. The image height, hi, is negative if the image is inverted relative to the object. The image gets inverted when the object is further than the focus from the mirror. Normally when you put the object closer than the focus, you get a magnified image, but it's a virtual image, which means it appears behind the mirror. In all the other cases, you get an inverted image, which is under the principal axis as when we draw it. And I've given you an example over here to show you what all the variables mean. So DO is the distance to the object. Here's an object. I drew an arrow a certain distance from a spherical mirror. And the distance to the mirror we're going to call distance of object. So it's from here to here. We've drawn 2 rays to locate where the image appears. So I drew the first ray hits the mirror and passes through the focus. The second ray passes through the focus and then returns parallel to the principal axis of the mirror. Where those 2 rays intersect is where the image is going to form. And we see in this case that the object is further than the center of curvature. So when we do that, we get an inverted image that is smaller than the height of the object. See, the height of the image is smaller than the height of the object in this case. And there are several cases. You can have the case where the object is closer than the focus, on the focus, in between the focus and the center of curvature, on the center of curvature, or further than the center of curvature. We covered that in the video on the 5 different cases for a mirror. I've given you a legend here to show you what each one of these subscripted variables means. So height of image is hi, height of object is ho, distance of image is d sub I, and d sub o is distance of the object. First question asks, a concave mirror has a focal length of 6 centimeters. An object with a height of 0.6 centimeters is placed 10 centimeters in front of the mirror. Calculate A, the image distance, and B, the image height. So we're going to use 1 over the focal length is equal to 1 over di plus 1 over do. The focal length, we're told, is 6 centimeters. So 1 over 6 is equal to 1 over di. That's the distance of the image is what we're looking for in part A. And we're told that the object is 10 centimeters in front of the mirror. So the distance of the object, do, is 10. So that's how we can fill in the variables that are in our equation. Whenever you have an equation with 3 variables, if you want to solve the equation, you have to know 2 of the variables. So here we know 2 of the variables, the third one is missing. We're going to transpose the 1 over 10, that's why we get 1 over 6 minus 1 over 10 equals 1 over di. Then we find a common denominator. In this case, the common denominator of 6 and 10 is 30. Actually, it's not the common denominator, it's a multiple of, common multiple really. 5 times 6 gives you 30, and 3 times 10 gives you 30. So we're going to multiply the numerator in this case by 5, and this numerator is going to be multiplied by 3 to keep the fractions to have the same value. 5 minus 3 gives you 2, so 2 over 30 is equal to 1 over 15 when you put it in lowest terms, and 1 over 15 is equal to 1 over di. Since you have 2 fractions equal to each other, you can flip both of them, and it'll still be an equivalent expression. Di over 1 is equal to 15 over 1, therefore the distance of the image is 15 centimeters. The image appears 15 centimeters in front of the mirror. The result is positive, so we can say that it's in front of the mirror. If we had a negative number, then we could say the image is appearing behind the mirror. In the second question, we're asked to find the image height. And so we're going to use the other equation. Height of the image over height of the object is in proportion to the negative of the distance of the image over the distance of the object. We know 3 of the variables, and there are 4, so that has to be the case. If you have 4 variables, you need to have 3 of them to solve for the 4th one. So we know that the distance of the image is 15 centimeters behind, where do we find that? No, sorry, the image is, the distance of the image is 15 centimeters from the mirror, but the formula contains a negative number, that's why we're putting negative 15. Okay, if the image was behind the mirror, then you'd have negative of negative 15, it would become positive. So just be aware of that so you don't get confused by it. We know that the image is the object is 0.6 centimeters tall, and that it is 10 centimeters in front of the mirror. So the height of the image can be solved for by doing a cross multiplication. 10 times hi is equal to 0.6 times negative 15, which I've written over here. 0.6 times negative 15 is negative 9. So 10 times the height of the image is equal to negative 9. We transpose the 10. Height of the image is negative 9 over 10, which is equal to negative 0.9. So this result shows the image is larger than the object and that it is inverted. So you get a magnification of the object between the focus and the center of curvature. However, the object is going to be inverted.